Okay. The title of this presentation is Embrace the Evolution of a mobile application product, Mindset and Tools for a domain test-driven design approach for mobile application development. This presentation is split in two parts. In the first one, I will describe some key concepts associated our approach, development approach. In the second part, Alex Gotev will show you a concrete example with a running mobile application. Okay, sorry. Just a note about this picture. We have two keywords, test and mocks. These two tools allow us to adopt a test-driven development approach. And we will see detail in the next slide. Just a few words about the environment. We have two entities, mobile application and backend server, and they just exchange data models. A few words about the layers, too easy the presentation in the next slide. Mobile application is composed by domain models, service API, they perform HTTP request, application service, usually they are aggregator of service API. And then we have, okay, here we have optional layer according to the adopted architecture. And finally, we have our presentation view layer. From the backend server side, domain models and an HTTP server. Okay. For evolution of a product, we mean a new feature, user story to implement over the time. Usually, a new story implementation implies edit or write source code belonging to different layers of a mobile application, new service API, new version of domain data model. Okay, here we have a contract, a Swagger file. It's a contract between backenders and frontenders. And in the Swagger file, we define APIs and models. Once we receive from business a new feature, when a new feature is defined, a user story, usually we generate a new Swagger version. And when we have the new version of Swagger, we start the development process. One of our goals is to write the minimum amount of code given new Swagger version, so a new user story. And from the Swagger file, we start the process of code generation, and we generate classes, artifacts belonging to these two layers. The other one remaining unchanged. Here we have an example. It's a pet. Alex will show you a pet mobile application. We also generate service API. And also we generate mocks. When we speak about mocks, we mean type-safe mocks. We don't use a JSON file to mimic the HTTP response coming from the server. And one thing to note is that for each mandatory field, we defaulted with a random value. Okay, in this case, we have name is a mandatory field, and we default with string mock. Mock is a function that returns a random string. Same things for enum. Okay, another goal that we have is to reduce friction during user story implementation. We have solved this problem, and now developers don't wait for API implementation by backenders. And we achieve this goal using a test-driven development with the help of SkyTest Foundation framework. Another goal is to prove the implementation correctness, and again, test campaign with Skytest Foundation. We developed Skytest Foundation in 2 years. We are using in our production application, and it provides a domain-specific language for testing. It's available for Android and iOS platform. And with Skytest Foundation, you can mock HTTP response received by the app, define assertion on each HTTP request sent by mobile application and received by the mock server provided by the Skytest Foundation, assert UI elements exist in view hierarchy, like please login, for example, and simulate user gesture like tap, swipe, and so on. Okay, our mobile application is available on Apple Store and Google Play. So we have 2 teams, one for Android and the other one for iOS. But we want to write a test only once. We want to have only one language to describe an expected behavior. And we adopt a copy-paste approach. So you write test one. The copy-paste approach consists, you can write a test in Xcode and copy in Kotlin Android Studio or vice versa. So you start writing your test in Android and copy in Swift code. Usually, a feature is implemented in pair, an iOS developer with an Android developer. Okay, here we have an example. This is a test, and you can see it's equals. We have just little differences due to the different programming language, due to the difference of the programming language. And now I will underline these differences. Okay. Okay, why we want to write, sorry for the confusion, okay. We want to write the test, we want to describe the expected behavior only once, because we don't want to waste time in translating a description, a test from one language to another one. And also, with the copy and paste approach, we reduce the probability to introduce error during translation. So you write your test in Swift and you copy in Android with little difference. Okay. Sorry, but okay. Now my part is almost finished. I just show you 2 examples. Suppose we have the following user story. As a user, I want to log in so that I can see a list of available pets. The user story is composed by two views, login form and pet list. Just again, an overview of our development process. So the user story is defined. We generate a new Swagger file. We generate a domains model, and we update our mobile application target. For target, I mean Xcode target. We generate service API, and we generate mocks, and we update our test target, UI test target, and we also include the Skytest Foundation. We will use mock to define HTTP response, again without JSON file. It's difficult to maintain it. We have, every time we generate and we start the generated process, we update our models and also mocks. So also our tests are updated. We don't manually update test. And then, okay, this layer unchanged. Some details, technical details about the user story. So the user should type text, Alessandro into username, password, tap login, perform request to the server. The server is, in our environment test, we have a mock server. So the mock server responds with a successful response. Again, the app requests a pet list. And finally, we want to assert the existence of Tom name in the pet list. Now we can see how we translate this user story, how we describe this user story using domain-specific language provided by SkyTest Foundation. So, given section, we define HTTP response using our generated mocks. We define routes. HTTP server builder is provided by SkyTest Foundation. We define the second route, HTTP route, required by this user story because we want to show a pet of list. We start the mock HTTP server. We launch the app. We assert the existence of please login text in our login view. We type Alessandro in user field, so credential, tap login, and we assert the existence of Tom name in our pet list. Here you can see some sort of invariance, okay? You have Tom here, and you have Tom here. This is always true. It's our testing approach is inspired. It uses a black box test techniques, and we look our application as a function. So in the given section we have inputs, and in the then section we have our outputs, and we define constraint on these two entities. The last one before Alex Gotev is, as user I want to type invalid credentials so that I can see invalid credential alert. Again we have to view, sequence diagram. Right now the mock server returns an authorized code, and so the app should show an alert with an invalid credential text. So we have to assert the existence of this UI component. Again, in the given section we define our HTTP route. We start our mock server. We launch the app. Again, we assert the existence of please login. We fill the form with the credential, login, and then we verify the existence of invalid credential text. Okay, and we tap OK button, and we also verify that invalid credential is not visible anymore. And our test pass. Okay, now I invite Alex Gotev.
Thank you, Ale. Can you hear me? Okay, thanks. Thank you, Ale, for a presentation. So now it's time for a demo. I'm going to switch to Xcode, fasten your seatbelt, and let's hope it doesn't crash, as it usually does. So, let me just stretch the screen. Maybe I should get the microphone so it's easier. So let me just stretch it. Okay, so as you've seen before, we have made a way to write not only your tests, but also your mocks and your HTTP web server entirely in Swift. All this thing is inside our test foundation framework, which we're going to see in some detail now. So let me just run this test. And so as the test runs, you can see some logging details. So you can see instantly what things are inside our HTTP server, what routes do we have defined, and what our HTTP server does respond to each route. So then we can assert the existence of elements on the screen. So all the things that you are seeing are based on XCTest underneath. We've just basically written a thin layer over XCTest framework. We've done the same with the support of our Android team for Android, based on Espresso. So by using SkyTest Foundation, you're basically using all that Apple and Google provides you, but in a simpler, for us at least, way to express the test. In a way that we are using currently, also to display new user stories, new features, and new implementation to our stakeholders, to our product owners. So we don't make any presentations for this. We just spin up Xcode or Android Studio, and basically we just show them right away the test. And so, for example, another thing which you can do when you're developing a new feature, you can start writing your test. You can start by defining all the routes, and basically, if you add a breakpoint at this stage, what happens? The execution will stop right away. And so if you're spotting something which is not okay with your application, you can do step by step. And so you can see all the steps executing on your command. So you can see that at each step you can debug and see if something's wrong, and basically just correct it. But okay, this is fine, but how then are we going to implement a new feature? So one of our goals is to write the least amount of code to support a new feature. So to do this thing, we have basically used the Swagger CodeGen. In accordance with our backend engineers, we are writing the Open API specification, so we are writing it together. And so we are not detached from them. We work in pairs. And with that approach, we were able to start developing the application without even the API server being ready yet. How many of you start developing the app without the backend server being ready? Okay, so it's a common thing. Usually, you know, in the university, you've been told that you start implementing things from the data layer, from the data owner, right to the front-end application. But what we've seen in production and on big projects is that it happens exactly the opposite. We are the fastest ones because our organization are always slower than us. We have faster cycles, we have great toolings, we have many things which our community gives back to us. So we also use Sorcery, we're using many other toolkits, and Apple has many new features for us. So let's dive into the next part. So I'm going to it's a little difficult with one hand. Okay. So what happens here, I wanted to show you the full process live, just to be able to show you that nothing's fake, everything is working. So we have defined two YAML files. So the first one is the one that you've seen. The second one is a new YAML file which contains a new endpoint definition with some new models. And so we now can see that the Swagger code gen, which we're using, it's embedded right here in our demo application. Let's see what it has done. So as we see, our backend engineers have defined some new things. So what they have defined? They have defined a new endpoint, which is suggestions with some new data models. And here, basically, what you can see is that we have created a new API implementation. So we don't actually code the actual call to the server by hand, but we get it auto-generated. We auto-generate the model, and it's a struct which is codable and hashable. And then we also auto-generate the mock. So we can use also the mock right away in our test. You can use your new model.mock. And so you can also inject all the things inside it. We provide a basic implementation which adds all the parameters with their default states, with random strings, random integers. We are working on adding some semantics, but it requires some little work. So the other files which you see that have been changed are basically commenting some of the demo code to not bother you with some boilerplate stuff. So let's dig into Xcode. We just have to clean and build. Basically, what happens underneath is that when you launch our code generation, a new SPM package gets auto-generated underneath with all the SDK stuff. So APIs, models, and mocks. And basically what you do is you import those in your application. So you import mocks in your testing, and you import the SDK, which is completely auto-generated in your app. So let's see what we have added here. As you can see, we have added some food tests. And what we see here is that we have added some food suggestions, and everything is written in Swift. So what happens if the backend drops some older APIs or adds new ones? If something which is breaking change, when you clean and build, Xcode will notify you, oh, this API is not available anymore. So let's run the test. It's a little longer. And also, it starts from the login screen. It fills in all the credentials, and then it navigates to the details. It may be a little fast. But one thing which comes to mind is you have a lot of tests. You don't want to be doing all the things from app launch to the exact position in your navigation. So how do you do that? It's beyond the scope of this presentation because it's a little longer, but you basically can define your application state in whatever way you want. So the SkyTest Foundation is agnostic to any kind of storage which you have defined. And this is it, but I have something else to show you because there's one more thing. And this one more thing, I would like to do it with you today because we are announcing SkyTest Foundation iOS. We're releasing it now, live on stage, here from Swift Heroes. So just a little moment. Let's hope the DNS does all the things right. Yeah, you know, login stuff. It's for real. And boom, it should be public. So we haven't finished yet, but we are using this to test our MySkyUp application. It's has been published in 2020. We have faced some critical issues when we went remote. So we accelerated a lot on this framework, and we wanted to share with the community as soon as possible. And we found this huge arena here that is absolutely awesome to launch it. And so we now currently having 2 million users. We have 99.9 crash free on the application, and we have achieved 85% of code coverage, all with SkyTest Foundation. And if you want to download it here, and you can explore all the things which I've shown you, and we're ready to take some questions.